let's take a look at some of the things we can do in Excel to model randomness. First thing we're going to look at is the rand function. Let's control tilde here. And that doesn't seem to be working. There we go. Okay, so when I've got the equal rand function, cell right here, I do need the empty set of parentheses for this to function, and what it does is generates a random number between 0 and 1. So if you type this into your Excel sheet, the equal rand parenthesis parenthesis, you're probably going to see a different number than what I'm seeing right here. If you press the F9 key, you'll see it regenerate a new random number, always a number between 0 and 1. And we're going to use this quite a bit. As far as the F9 key, if you're on a compact keyboard, you may need to first press the Fn key at the bottom of your keyboard, then press the F9 key at the top of your keyboard. If you've got a full-size keyboard, there's probably an F9 key right there. Okay, the second function we're going to use is the randbetween function. And the randbetween function will generate integer values, integers, whole numbers, positive or negative, between two values. And we control tilde here and make that a little wider. So this one I've got set up equal randbetween -1 to 4. And so if I hit F9 a few times, I'll get random numbers between -1 and +4. There's my -1, there's my +4, and every integer in between. Now where we use the randbetween function the most is for simulating a fair die. A fair die has 6 sides, each equally likely. And so if we use randbetween 1, 6, we get random numbers from 1, 2, 3, 4, 5, and 6. And again, we hit F9 a few times, and you can see in that dark green cell, I'm getting random numbers 1 to 6. Now, using these rand and randbetween functions in conjunction with the if function, you're familiar with the if function from previous modules. The format of an if function, type that in here real quick, equal if logical test, comma, value if true, comma, value if false. And what I've got set up here, if a random number is less than 0.5 heads or tails. So if the random number comes up less than 0.5, this cell will display heads. If it comes up greater than 0.5, it will display tails. And so I can simulate flipping a coin this way. And half the time I'll get heads, and half the time I'll get tails. Okay, so you can see how I can set up some basic gambling situations, rolling dice, flipping coins, and use those to solve some problems. Let me take a look at my next sheet here, shell game. And change the screen here a little bit. So shell game, we've got a button hidden under 1 of 3 shells, and then the shells are shuffled, and we're going to guess whether or not we get the correct shell. So since there's 3 choices and only one is going to have the button, I've set this up. I've got a random function here, equal rand, and then my function here is if that random number is less than 1/3, win, otherwise lose. So 1/3 of the time I should come up with win, 2/3 of the time I should come up with lose. And again, hitting the F9 key, I can simulate playing the game. Now to do this 100 times, do 100 iterations, I've got my split screen, already set up. And down here I'm going to go to cell, let's see, 105. And so I can take this down, and I can simulate playing the game 100 times. Now the problem with win and lose is it's a little difficult to count. So what I'm going to do here is go ahead and change my function. instead of win and lose, I'm going to use 1 for what to do if true and 0 for what to do if false. The reason the 1 and the 0 is handy is I can count up the number of successes. Let me restate that. So if a random number comes up less than a third, that's going to count as guessing the correct shell, finding the button. And so 1/3 of the time I should get a 1, and 1/3 of the time 2/3 of the time I should get a 0. And so now if I sum up these 1s and 0s, in 100 games I had 32 successes. I won 32 times. And so that helps me estimate what I certainly expected. My theoretical probability of winning this game is 1/3. My empirical probability is the number of wins divided by the number of times I played the game. I played it 100 times, and so my probability of winning is 36%. But notice every time I hit F9, I regenerate, and I'm getting empirical probabilities that are all close to 1/3, but with random variation, I'm not going to hit that exactly every single time. So let me do the little labeling here. The 44 is the number of wins. Text there. And this value is my empirical probability. So based on observations, so empirical, assuming you spell it right, empirical probabilities are probabilities based on observations rather than based on theory. Theoretical probability of winning this game is 1/3. And for this particular iteration, my empirical probability based on experience, my probability of winning is 0.32, which is very close to 1/3. Now, if you want to get a little fancier with some of these setups, let me copy this. Let me go back to the win and lose. You don't have to do this. The 1s and 0s are great. But if you do use the 1s, and if you do like to use words, heads and tails, win and lose, rather than 1s and 0s, what we'd want to do here, instead of sum, is something called a count-if function. Count-if, I'm going to keep the range here. We got the word win. There we go. So this way, instead of displaying 1s and 0s for winning and losing, we're actually displaying the words win and lose. And then the count-if function counts up all the times the word win appears. So just makes your spreadsheets look really nice.